Hey everyone, welcome. So today we are going to do direct proofs. Okay, so let's get into it. So firstly, before you begin to solve for a direct proof, you need to know what you're solving for. So firstly, this is the rules when you're going to do a direct proof. P implies Q. So P of X is your first statement and Q of X is your second statement. So when we solving, we assume that P of X is true and we show that Q of X is true. Okay? Awesome. So for this example, we are going to prove that the product of two odd integers is an even integer. So the first thing you do is you're going to write down this is the proof that you're doing, okay? And secondly, we're going to find out what's our P of X and our Q of X. Firstly, if you look right here, where do we get it from? Well, we get it from what we're given. And if you look here, this is our first statement, that the product of two odd integers, the product of two odd integers. And our second statement would be that it's an odd integer. So how does that look? How does this look in words? Well, this is how you would phrase it. You put P of X, semicolon, let the product of two odd integers be m and n, such that m times n. You could use other letters if you want to. I just use m and n. It's just easy. So let the product of two odd integers be m and n, such that m times n. Okay? And then we have Q of n. So we say let m times n be odd. Okay? Then we say since P of X is true, okay, because you have to state that P of X is true for a direct proof. Then we're going to say m equals 2k plus 1. And what's our P of X? Is that the product is odd. That is why we have 2k plus 1. If it was even, it would just be 2k. In this case, it's m equals 2k plus 1 and n equals 2t plus 1 for some integers k and t. And then we simply solve for m and n. So we say that m and times n is equal to 2k plus 1 times 2t plus 1. And we begin to FOIL, which gives us this. And then we break it down. Okay, we break it down because what we want to do is we want the inside of this. Okay, we want to come back to show this term here, all right, excluding k, of course, but we want to show that m times n is odd. And to do that, we're simply going to replace the inside here by a variable. So we'll say 2 times e plus 1, where e is equal to what we have inside. And thus, m times n is equal to 2e plus 1 for some integer e. You have to say this as we've said it here. We just didn't put it here. Whence Q of n is true. And this is how you would word and phrase and solve for a direct proof such as this. I hope you enjoyed this. And if you did and you found it helpful, like, subscribe, hit the notification tab and share it with a friend. Cool, and I'll see you in the next video.